Great. So welcome to today's class. I hope you're having a great day today. Please, just a reminder, make sure you have your notebook with you writing something down. It's important that you write something down. It's very, 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 very important that you write something down. It's so important, okay? So I want to encourage you, please write something down. Write something down, okay? Great. So we want to look at this together. We're going to go through, just wrap up our last class. So our last class, we ended with being able to describe redox reactions, be able to identify the reductant, oxidant. We're going to look at, so from your last class, there was an exit ticket from your last class that we want to just look at real quick. Okay, so that was the exit ticket from the last class. We're going to look at it together just to see how you went about it. Just to see how you went about it, okay? If you tried it on your own, we're going to do it together just to see how you went about it, okay? So what was the bell ring? After that, we're going to look at something very important. It's called balancing redox reaction. Now, this is something important. It's critical, and you want to pay attention. Okay, so follow through. Take your time. If you don't get it, go back, rewatch this video, rewatch it till you get it. That's the whole point. There's no need to rush. Go back again, try and understand what is going on. Okay, try and understand what is going on. So let's start. So we're going back to this bell ring, guys. Exactly what was your exit ticket from the last time? Okay, so that was your exit ticket from the last time. So if you tried it, I guess it's time for you to do. This is just going to be a revision for you. Maybe you tried it, you had it, you didn't know whether you're right or wrong. You're going to find out very soon if you were right or wrong. Okay, so let's try this together. So we have an equation. Our equation here is they're saying that this equation is the production of tin chloride. So we have tin. This is tin. If you don't know, the chemical element for tin is Sn. If you're expecting something to start with T, well, you're wrong. So tin is the chemical element for tin is Sn. Now they're telling you that tin is in its solid. That means that is just the element of tin. So tin is in its elemental form. So we have tin here in its elemental form reacting with HCl. Okay, HCl, and it produces tin chloride. Tin chloride, which is in a solid form, and it releases what? H2, what is hydrogen gas. So straight away, if you remember what we've been studying, there's something here that's important. To know if it's a redox reaction, we have to analyze it first. How do we know if it's a redox reaction? We said that if it's a redox reaction, there's going to be a change in its oxidation state or its oxidation number. So let's try and see if there's any changes in oxidation number. So tin is just tin sitting here. So it's 0. The oxidation state here is 0. It's just tin in its elemental state. So the oxidation state is 0. Now let's look at tin here. Tin here is combined with chlorine to form a compound. The only way it's existing as a compound is that there had to be a reaction going on. So tin was alone on its own, chlorine was alone on its own. To be combined, chlorine, the oxidation state for chlorine is -1. Tin is +2. Okay, look here. It says tin 2 chloride, means the oxidation state for tin is, this tin is tin 2. So tin is one of those metals that has variable oxidation states. And in this particular reaction, tin is existing as tin with the oxidation state of 2. Okay, tin with an oxidation state of 2. Great. Tin with an oxidation state of 2. Interesting. So let's move on. Just so you know, there are two different kinds of tin. So we have tin 2. When tin is existing with the oxidation number of 2, we call it tin 2. Tin can also exist with an oxidation state of 4. Then we call that tin 4. So we're dealing with tin 2 here. So it was just tin in its elemental state. The oxidation number is 0. There's no charge. But now tin has to combine with chlorine to have formed tin chloride. The only way is that tin was plus 2 here and chlorine was minus 1. So look at the change in the oxidation number. Here it's 0, now it's plus 2. What that tells us is that straight away this is a redox reaction. So our first response is that yes, it's a redox reaction. Okay, that's the first response. It's a redox reaction. Because we're seeing a change in the oxidation number. Once there's a change in any oxidation number in any of the elements, there's a redox reaction going on. So we have settled that. Now, which type of redox reaction? Now, this one I need you to think and remember what we've been doing. Remember, we spoke about a type of oxidation reaction, a redox reaction called single displacement or single replacement reaction. We said that a metal replaces an ion. Now, if you've not realized, tin is a metal. The moment you saw a metal sitting here, know that it's likely to be that kind. So let's see if it's that one. We said in a single displacement or a single replacement reaction, the metal is going to displace or the metal is going to replace an ion. So we have tin here and tin is here, but we have an ion. The ion we have here, we have H. Look here. In this state, in this compound, chlorine has hydrogen ion combining with chlorine to form hydrogen chloride. But look at what happens here. Chlorine is no longer there. Look at here. Now tin has replaced chlorine. Sorry, tin has replaced hydrogen. Hydrogen was combined, but now hydrogen no more. Now hydrogen rather is now here releasing as a gas. It's coming out of the gas. So this is the type of redox reaction we call single displacement reaction. Displacement single displacement. You can call it single displacement or single displacement reaction. That's how, so this is a single displacement reaction. So we just found the specific name. So we just answered that question. Specific name. Now the last, we need to know which one is the oxidant, which one is the reactant. To help us know which one is the oxidant and which one is the reactant, this is simple. Let's think about it this way. Think about it this way. We need to know which one is the oxidizing agent, and that's the same as the oxidant. We need to know which one is the reducing agent, which is the reductant. To know that, we need to know which one is undergoing oxidation, which one is undergoing reduction. So let's look at it carefully. So we know that chlorine, which is chlorine here gains an electron. Do you see that? Chlorine gains an electron. Chlorine gains an electron. Now, chlorine gaining an electron means that, so chlorine here was from this compound. So HCl undergoes reduction, right? HCl undergoes reduction because the chlorine inside here gains the electron, so undergoes reduction. So undergoes reduction, which means that it is the oxidizing agent. Okay, so it means it's the oxidizing. Oh, sorry. Oh, oops, oops. The pen. Um, oxidizing. Oh my. You know what? Let me just write it. So that's the oxidizing agent. Oh, no, no, no. Oh, no. I just cleaned everything. So, you know what? Let's just continue from where we left off. So, we just concluded that the HCl is going to be the one undergoing. If you didn't write what I just wrote, you can just go back. We play the just go backwards like 1 minute and write down what you saw. So HCl undergoes reduction. So means that that will be the oxidizing agent. Okay, or oxidant. If you want to see what I wrote earlier on, just play back, go backwards like 1 second, 1 minute. You see all the things I wrote, you can pause, write it down because I accidentally clicked on the clean and it cleaned everything. So you can go back and write it in your note. I want you to have it in your note. That's what I'm telling you, that oxidant. And we concluded that so the tin is going to be the one that undergoes oxid oxidation because that is the one that loses the electrons, because tin is going to exist as Sn plus 2 here. Chlorine existed as Cl minus here. So chlorine gained the electron, tin lost the electron. So Sn, which is the tin was the what? The one undergoing or undergoes, anyhow you want to put it, undergoes oxidation, because tin is the one that loses the electron. So tin undergoes oxidation, which means tin is also the reducing agent. Okay, reducing agent. I hope you're following. So we're just refreshing our mind on what we learned the last time, or which is the same as the reductant. Reductant. Great. And that's about it for this one. Great, great, great. Now remember we said that this type of reduction is called what? Single displacement reaction. So we can write it somewhere here. The type of reaction is single displacement reaction. Single. We know that because we see single displacement. We learned about it last time. Oh my, this is difficult. Single, you know how to spell displacement, right? So I'm trying to write displacement. Oh my, help me. Single displacement reaction. We know that because we see H was the ion here, but now H is no longer here. What do you see? Tin, which is the metal, has replaced. Look, so tin takes the place of hydrogen in this compound, and we have tin chloride instead of hydrogen chloride. So we said that in a single displacement reaction, we learned it last time, a metallic element removes or displaces or replaces an ion. Okay, so the ion here, which was H plus, is replaced by tin, which is the metallic element. And that kind of redox reaction is what we call what? The single displacement or single replacement reaction. So this was your bell ringer from last time, and I just decided to go through it together with you. I started by explaining how the various elements came together. If you want to see that, just go backwards. You're going to see that I explained that, then I cleaned the screen to write all these. So you can go back like 3 or 4 minutes or 5 minutes when I started explaining this. Write it in your notebook, try and understand what is going on. Okay. We're getting into the deep parts of chemistry, so it's not going to be always fun, 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 and that's totally fine. Any question on that? Anybody has any question on this? Any questions? Any questions? Okay, no questions. I guess we're all good. We're all good. Great. If we're all good, then we want to go to actually the main deal for today. The main deal for today is we're going to look at balancing redox reactions via half reaction method. Now, we remember when we're doing half reaction, I told you half reaction is going to be important when we start doing balancing. Now, if you don't remember, we've done normal balancing of equations. In a normal balancing of equation, we try to look at the elements on the left hand side, element on the right hand side, then we count them. We count them. If, let's say, carbon. So if carbon has 2 on the left, it has to have 2 on the right. If hydrogen has 4, then it has to have 4 on the right. When I say right, I mean, let's say A plus B produces C plus D. So this is the left hand side of the equation. We call those what? Reactants, for anybody who forgot. Then C plus D, that's the right hand side of the equation. We call those products. So when you're balancing a normal equation, we're trying to make sure that the number of atoms on the left hand side is equal to the number of atoms on the right hand side. If they are not equal, we have to do something about it, right? So let's say this was 1. They are not equal. So then we multiply the 1 by 2. So that now we have 2. Then you're equal. Multiplying by 2 means that you find where this element is. So where C was on the right hand side, we put a 2 here. Let's say this is the compound that had carbon. We put 2 here and now we balance it. Okay. This is what we learned previously about balancing equations. In balancing redox reactions, it's more complex. We have to follow all these rules. So number 1, number 2, number 3, and number 4, number 5, number 6, number 7, number 8, and finally number 9. As you can see, this is a long list of rules that you need to pay attention to when you're balancing redox reactions. So the first thing I need you to do is to write down these rules, because I don't expect you to put everything into your head. Like, I don't expect you to commit it to memory. I expect you to have them written down so that they can guide you. Okay. So the first thing, please write these rules down because we're going to need them as we try to balance redox reactions. We're going to have to follow these carefully. Step 1 says do this. So step 1, you do exactly what step 1 is saying. Step 2, you do step 2. Remember I told you chemistry is not difficult. Chemistry is just following instructions. Okay. If you don't follow instructions, then you never really like chemistry, because if you try to just skip the instructions and do what you want, you're going to have a big problem. Okay. So that's the first thing. I want you to write down these steps. So step 1, each of the things you see in step 1. So step 1 says what? Let's see step 1. Step 1 says Write the two half reactions representing the redox process. Remember, we learned how to write half reactions. We learned how to write half reactions. In case you forgot, oh my, in case you forgot, I'll have to help you to remember. I'm going to try and help you to remember real quick. But step one says, write the two half reactions. Write the two half reactions. It says, write the two half reactions. In case you forgot, this is the best I can do to help you. We said that half reactance is when you take one element on the reactant side, the left hand side, just take only that one, and you describe what is happening to that element on the product side. Imagine that is the only element in the reaction. Don't include the other element. So let's say we have an element. I'll have to use an example right now. So let me clean this so that we try and write an example of half reaction. The first step in redox reaction, balancing redox reaction, is that number one, you have to write the half reaction for all the two reactants you have. So for the two reactants you have to write the half reactions for both of them. So if you don't know how to write a half reaction, then you're in trouble because you need to go back and remember how to write a half reaction. So I'm going to help you real quick if you've forgotten, because the first step is to write a half reaction. So let me see if I can help you to remember if you've forgotten how to write a half reaction. So let's clean this real quick. I'm going to use this little space I have here. So we're trying to remind ourselves how to write a half reaction. That's for anybody who forgot how to write a half reaction. Okay. So let's say I have a reaction Na. Please pay attention carefully. I'm just trying to remind you. I have Na in a solid form plus Cl2 here in a gaseous form. So these two elements are in their elemental substance. Sodium is supposed to be solid in its elemental state. Chlorine is supposed to be a gas in its elemental state. So these are two elements, two chemical elements, the elemental state. We're forming a compound NaCl. NaCl, which is solid. Do you see that? Great. So if you're told to write a half reaction, so half reaction means you pick only one element on the reactant side. We have sodium and we have chlorine. So let's start with writing a half reaction for sodium. I'm just helping you to remember how to write a half reaction. So a half reaction for sodium is going to be, you write only sodium. Now, sorry, I didn't complete my reaction. So in the reaction, sodium had two here. Yeah, yeah. So now let's come back. So we want to write a half reaction for sodium. We are going to assume that only sodium is the only thing in the reaction. So pretend that chlorine is not here. So pretend chlorine is not here. Sodium on the left hand side, we have two sodium S. So I pretend there's no chlorine. So I put my arrow here and I write only what is happening to sodium. Okay. So what is happening to sodium? Sodium now has two in front of it. That's all that is happening to sodium. And this should be my half reaction. Okay. But this half reaction, so that's all I want you to remember, how to write a half reaction. But remember, this sodium is not just sodium as this sodium is combining with chlorine. The only way sodium could have combined with chlorine is that sodium was existing as sodium plus, chlorine as existing with chlorine minus, so that they combine and they form sodium, and it takes the one from the chlorine Chlorine also takes the 1 from sodium. Then we have sodium chloride. So meaning that sodium was existing as an ion. So that's the whole point. So then this is the half reaction. Sodium was a solid with zero charge or zero oxidation state. Now sodium becomes sodium with a +1. The oxidation state has changed. Okay. So this is just a simple half reaction for the redox reaction that was above there. Okay. So this is a simple half reaction. I'm just trying to help you remember how to write a half reaction. So if you're asked to write the half reaction, this will be the half reaction for sodium. Now let's write a half reaction for chlorine. This half reaction is not balanced though, but for now just leave it like that. We're going to learn how to balance. Let's write a half reaction for chlorine. So now we're going to pretend that only chlorine is what is in this reaction. So it means you pretend there's no sodium. So if I'm pretending only chlorine is what is in this reaction, I'm supposed to have chlorine sitting here with a 2 down here. Then I have the G, which is standing for gas. Then I'm going to have my arrow for chlorine. And I'm going to pretend only chlorine. I remember what we said here. So I mean chlorine is also existing as an ion. I have chlorine minus here. And remember there's a 2 in front of sodium chloride. So there's a 2 also. This 2 affects sodium. This 2 also affects chlorine. Okay. So this will be the half reaction for chlorine. So I have a half reaction for sodium. I have a half reaction for chlorine. Okay. And that's it. We have a half reaction for chlorine, half reaction for sodium. Any questions? This is just a recap, okay? This is a recap. If you don't remember or you're lost, I'll just encourage you to, at this moment, pause, go back to what we did under the beginning of redox reactions, because you're going to need that. If you don't remember, just pause, play this video back, go back to and watch how I explained writing half reactions, because you need to remember how to write a half reaction to begin balancing redox reactions. Does that make sense, everyone? So I just tried to help you by going backwards and repeating what we already learned, which is called half reaction. So now I've just repeated that. So now you know what a half reaction is. So to balance redox reaction, we're saying the first step is what? The first step is to write 2 half reactions. So look at your main reaction you have. Write 2 half reactions for the redox process. So one of the reactions will be the reduction. One of them is going to be the oxidation. So if you look at these 2 here, which one do you think is the reduction? Which one is the oxidation? Remember we said in reduction you gain electrons. So chlorine is gaining electron here. So this is the reduction process. Sodium losing electrons. So this is the oxidation process. I'm just trying to help you remember what we've learned already. You should have known this already because before already learned this. Okay. So sodium undergoes oxidation, chlorine undergoes reduction. These are the 2 reactants, and this is how we know which one is there. So once sodium undergoes oxidation, sodium becomes the reducing agent or reductant. Chlorine is undergoing reduction, so chlorine becomes the oxidizing agent or the oxidant. So that's what we're talking about here. Okay, so I'm just trying to remind you. All I'm doing is trying to remind you about what we've learned already. Okay, what we've learned already. Please, I hope you're following. Great, great, great. I hope you're following. So we're saying the first thing to do is what? Write 2 half reactions. After you've written the half reactions, balance all elements except oxygen and hydrogen. So that's the next step. The next step, you're supposed to balance all elements. So if you look here, we're supposed to balance all elements except what? Hydrogen and oxygen. So look at your two half reactions. So let's look at sodium. Sodium has two here. Sodium has two here. So in this situation, sodium has two here. Sodium has two. So sodium is balanced in this situation. Okay. But in this situation, chlorine has two here. Chlorine doesn't have two. So if I'm following these rules, I'm supposed to balance all the atoms, but I should leave oxygen and hydrogen. Don't balance those. So this is not oxygen, it's a hydrogen, so I can balance. So I can put two here so that now I have fulfilled this rule. So rule number one says right, or rule number two said balance all elements except oxygen and hydrogen. So I just did that. Now rule number three is that rule number three says it's time to balance oxygen. How do you balance oxygen? For the number of oxygen you have, add the same number of water molecules, H2O. So if I had 5 oxygen, I'll add 5 H2O to balance it out. We don't have oxygen in this example. We're going to find out. So imagine we had oxygen and we've just added 5 water molecules on the other side to balance it out. Now the next thing they're saying balance hydrogen. To balance hydrogen, how do you do that? Add H plus ions. So let's say I had 7 hydrogen on the left. I have to add 7 H plus on the other side to balance it out. The step 5 says that balance the charge by adding electrons. So step 5 is telling me to look at the charges. So step 5 is saying look at the charges. If I look at the charges, and let's say there's a charge on the left hand side and a charge on the right hand side, it's not the same. I need to balance it out, right? How do I balance it out? So I'm gonna do step 5. I can do step 5 in this example. Step 5 says balance charge by adding electrons. So let's do that here. You need an eraser. Look here. I'm just using this as an example. So the charge on this side is 0. Sodium is existing as its elemental state is 0. But the charge here is +1. Can you see that? But this +1 is being affected by this 2 sitting here. So actually the charge here will become, it's going to become +2. It was supposed to be +1, but because of these 2 now it becomes +2. So the only way to balance it out, we want to make it 0, just like the way this is 0. How do I make it 0? I'm going to add 2 electrons. Remember, electrons are negatively charged. So when I add 2 electrons, this becomes 2 negatives. So this is -2, and this is +2. They're going to cancel out. Then now we have a balanced situation here. And that's how we balance our charges. We're still sitting at step 5. So let's see if we have to balance anything for chlorine. For chlorine, step 5 says that balance it out. Chlorine has 2 sitting here. These 2 affect the minus here. So actually chlorine has -2. So to be able to balance it out, I need to affect the other side and make it also -2. How do I do that? I bring 2 electrons here. You see that? So that now what I've just done is that now I've made both of them have what? -2. That's what we're trying. We're trying to make it equal. That's what we're doing. Okay. Great. So I just fulfilled step 5. Now step 6 says that if necessary. So anytime you see if necessary, it means that it might not be necessary. If it's not necessary, you don't do it. But if it's necessary, then you do it. Step 6 says that if necessary, multiply each half reaction's coefficient by the smallest possible integers to yield equal numbers of electrons in each. We want to make sure that the electrons are equal. But in this case, the electrons are already equal. There's 2 electrons here. There's two electrons here. They're already equal. If they were not equal, would have multiplied through all the reactions, would have multiplied all the coefficients to make it equal. So let's say this was 4. Let's say this was 4. Okay. If this was 4, would have multiply everything here by 2, just so that this will also become 4. Okay. That's if that was necessary. In this case, it's not necessary, so we don't have to do it. Okay. It's not necessary, so we don't, because they are already equal. There are two electrons, two electrons. So that would have satisfied step 6. It says that if necessary, but it's not necessary. In this case, we don't need to do that. Step 7 says that add the balanced half reactions together and simplify by removing species that appear on both sides of the equation. So let's see, I'm going to try and fulfill step 7 here. I hope you're following me. I'm going to try and fulfill step 7. So let's fulfill step 7. To fulfill step 7, we're supposed to write all the half reactions together. So I have 2Na with the S, then I have plus 2Cl2 with a G, then I have plus 2E minus, then all of them give me, I have 2Na plus 2E minus, then I have plus 2Cl minus with an S. All I did was just to write the two of them together, like write everything together so that they are one unit. That was step 7. So I'm just following step 7. It says that add all the balanced half reactions together. After I've balanced them, write all of them together. So I've just fulfilled step 7. Let's go to step 8. Step 8 says that for reactions occurring, no. Yeah, so I didn't finish step 7. You said add them together and simplify by removing, look at what this says, by removing species. So let's read. By removing species that appear on both sides of the equation. So if there's anything that appears on both sides of the equation, that is the same thing. I have to remove it. So look at this side of the equation here. We have 2Na plus 2Cl2 plus 2E minus, that's an electron. We have 2Na plus 2E minus, that's electron, plus 2Cl minus. Which of them is appearing on both sides that we can remove out? Look at it carefully. I think that this should cancel this out because they're the same thing. That is what step 7 is telling me to do. So I just did that. By canceling those two, now step 7 has been fulfilled. Step 8 says that for reactions occurring in basic media, meaning that reactions that have excess hydroxide ions, you need to carry out the next steps. So it means that if you have a reaction that has hydroxide, if you don't know what hydroxide means that OH. So they're saying that for step 8, if you have a reaction that has, it's a base, means there's OH minus. There's OH minus inside the reaction. Then you have to follow the next steps. But in our case, we don't have OH minus, so it means we don't have to follow step 8. We jump to step 9. Step 9 says that finally check to see that both the number of atoms and the total charges are balanced. So final check. Check to see if both sides are balanced. So I have two Na here. I have two Na here. I have two Cl here. I have two Cl here. I don't know if you're following me. So we are doing the final check. That's what the last one. There's two Na here. There's two Na here. So sodium is balanced. There's two Cl here. There's two Cl here. So Cl is balanced. And now these charges already cancelled out. So it means, ta-da! We have a balanced redox reaction. And finally, we are good to go. So you see, we had to follow step one, but as you can see, some of the steps did not apply. So the steps that do not apply, you don't have to follow them. So it depends on the redox reaction you are dealing with. That is why I told you, write down these instructions, these steps, and follow them where they apply. And that is how we balance redox reactions. As you can tell, it's not going to be something that you can just skip. You're going to have to take your time, follow the instructions, and go through it. So are you ready? We're going to try an example together. Are you ready? Yeah. Please, if you've not written down these instructions, you need to write them down because you're going to need them to help you understand what we're doing. You're going to need them to help you understand what we are doing, okay? Great, great, great. So let's do this together. Let's do this together. Okay, okay. So let's try this together. Okay, so let's try this together. Let's go. So we're going to do this. We're going to now make sure I just gave you some time. Write down these 9 principles, 9 instructions. You're not going to use all of them every time. If they don't apply, you don't use it. So we're going to try and balance a redox reaction here. We're dealing with an acidic solution. Okay. Which color do you want to use? Let's use our favorite red color. So write a balanced equation. So let's read this together. Write a balanced equation for the reaction between dichromate ion. So think about it. Which one is dichromate ion? And ion 2. So straight away, I know that this is ion 2 because the oxidation number for ion is 2. They're telling you the particular ion we're dealing with is ion 2. If this is ion 2, dichromate ion should be this ion. So dichromate ion is that one. Ion 2 is this. And they're saying that when dichromate ion and ion 2 react, the reaction results in ion 3 and chromium 3. So we have ion 3 and chromium 3. Which one is ion 3? Of course, this will be ion 3. And which one is chromium 3? Of course, this is going to be chromium 3. I'm just helping you to identify various compounds. As I said, chemistry is not anything difficult. Don't get scared when you hear ions and hear stuff that you don't know what they are. Try and look through, read between the lines and see which what is it talking about. That'll help you to not be scared. So what is step one? Step one is saying that the first thing I need to do is I need to write down two half reactions. So I need to write a half reaction. Remember what we said? We said that first thing, know what a half reaction is. I already tried to remind you of what a half reaction is. So we're going to start by writing our half reaction. So let's write a half reaction together. Step one, I'm going to write a half reaction. So I'm going to start with the dichromate ion, which is this. This is dichromate ion. So I'm going to write a half reaction for dichromate ion. So I'm going to have Cr2O7, 2 minus. I'm going to pretend that that is the only thing because this is a single reaction. A half reaction. I'm writing two half reaction. This is my first half reaction. I have dichromate ion. It resulted in what? It resulted in Cr3 plus. I'm pretending that it's only dichromate ion I have. Okay. So I'm pretending like it's only dichromate ion I have, and that's what I have. That's my first half reaction, everybody. So my second half reaction, I'm going to write the half reaction forward for ion 2 because we said it was between dichromate ion and ion 2. So now let me write half reaction for ion 2. I'm going to use a different color. So for ion 2, I'm going to write my second one. So ion 2, I have Fe2 plus. Okay, Fe2 plus half reaction. Fe2 plus now becomes what? Fe3 plus. So we have ion 2 undergoing a half reaction. We have ion 3. Interesting. So straight away we can try and analyze this to see what's going on here. Do you want to analyze this? You want to analyze this carefully. So one of these is the reduction reaction, one of this is the oxidation reaction. Fe2 plus now becomes Fe3 plus. What is happening there? Fe2 plus had lost only 2 electrons. Now Fe2 plus is now Fe3 plus, means now in this case now it lost 3 electrons. So iron is losing 3 electrons. Iron is undergoing what? Oxidation. You can call it that. Okay. Okay, great. And dichromate, we see dichromate now. Dichromate now. Dichromate, our chromate here. So now to be able to analyze chromate, we need to now come and look into which oxidation is changing. That is not why we are here. So we can just leave that for another time. Today we're here to balance the reaction. To balance, the first thing is to write two half reactions. Have you written the half reaction? Yes. Half reaction 1 is in red. Second half reaction 2 is in yellow. So now what's the next step? Step 2 says that balance all elements except oxygen and hydrogen. Okay. So we're supposed to balance all elements except what? Hydrogen and oxygen. Okay, let's try that. So I'm going to make sure I keep it consistent. Anything with the second half reaction is going to be yellow. Anything in the first is going to be red. So that we don't confuse ourselves. Okay. So let me start with the yellow. Now, ion 2 doesn't have any oxygen. So it's just going to remain the same. I don't have to do anything to it because it doesn't have any oxygen. So ion 2, the same thing I had there. I'm going to write the same thing again. The same thing. Now, This the one in red has oxygen. They're saying balance all the elements except that. Okay. So let's balance all the elements except that. So we see Cr, we can balance Cr. So let's write it. Let's write it in red. So I have Cr. It was a Cr2. There's O7. There's 2 minus. It becomes it was Cr. It was Cr3 plus. I am balancing Cr. Cr has 2 here, but Cr is 2. You can see this 2. There's 2 here. There's nothing here. So there's 2 of Cr. So I'm going to balance Cr by putting 2 here. Do you see what is happening? I just balance Cr so the Cr will be balanced. They said leave oxygen and hydrogen. So I can't touch this oxygen. I'm going to leave it for now. So as you can see, all I did was to follow step 2. So we're done with step 2. Let's move on to let's try and move on to the next thing they want us to do. Please, I hope you're following. I hope you're following. Great. So I want you to write this down. I want you to follow me. So follow me what I was doing. So if you were not writing, let's go. Write the question down. Just follow me to this stage, wherever I've gotten to right now. Follow me. Make sure you understand. Let's do this. Let's write down. Great. So I'm expecting that by now you have written down and you followed me, at least you followed me to where I am right now. And I'm hoping, that's my hope, that you have been able to follow me to where I am right now. If you have not, please, let's do this together. That's the only way you can understand this. Okay. So we've done step 1. You've also done step 1 in your notebook. You're following me. Step 2, balance all elements except oxygen and hydrogen. Hopefully you have done that with me. If you've done that with me, then we can move on. If you've not, please, I want to encourage you. Do that right now. Don't watch this video and just be using your phone or something. It's going to affect you. You're not going to be able to understand what is going on. Great. So hopefully everybody has written. Let's move on. Step 3. So step 3 is just continuing from step 2. So it means that whatever we had in step 2, we're carrying it to step 3. So step 3 says that balance oxygen atoms by adding H2O. So to be able to do that, I need to write whatever I had. So let's go back. So in step 2, I had Fe2 plus, Fe3 plus. So remember, I'm just going to repeat that. That has no oxygen. That doesn't concern this. So step 2, I'm just going to repeat the same thing. Fe is not affected. It doesn't have oxygen. Fe2 plus still exists as Fe2 plus. It's Fe3 plus. I'm just repeating what I had in the previous step. It's not affected. In this case, what is affected is what has oxygen. So we had so we're gonna have to deal with the ones that had the oxygen. They are gonna be affected now. We had Cl2, we had O7, 2 minus. Then we had on the previous page we have Cr3 plus, and we put a 2 here if you remember from the previous page, just to balance out Cr here. Now it's telling us that in this step, balance oxygen atoms by adding H2O. So I have how many? Let's look here. How many oxygen atoms do you have here? You can see 7 here. This 7 is affecting oxygen. There's 7 oxygen atoms. So they're saying balance oxygen by adding H2O. So I'm going to have to add H2O molecules. How many H2O molecules? Because I need to balance 7 oxygen atoms. So I'm going to add 7 water molecules. My question is, where do I add the 7? Do I add the 7 water molecules to the left or to the right? Do I add the 7 water molecules to this, or I add the 7 water molecules to this? What do you think? Think about it carefully. Remember, the 7 oxygen is on this side. So if I want to balance it, do I come and add it to this side where the oxygen is already is? Or I add the water molecules to the other side to balance it? I guess I have to add it here. So I need to add the 7 water molecules to this side. Now the whole goal, the reason is that this 7 is affecting this 7. This 7 is affecting the oxygen. So it means that now I have 7 oxygen here. I'm going to have 7 with oxygen. So this is now balanced. Okay, so that's what we're trying to do. That's what we're achieving here. And now we're good. We just follow the step 3. Please, are you good to this point? Anybody who is lost at this point, who is lost? Anybody who is lost at this point? Anybody who is lost at this point? Okay, so we are all not lost. We are all on the same page. That's great. That's good. We are all on the same page. Okay, so then let's move on. Step 4 says that balance hydrogen atoms by adding H plus. Now step 4 says that find where hydrogen is and balance the hydrogen by adding H plus. So now we are going to balance hydrogen by adding what? H plus. So look carefully. Where do you have hydrogen? I have hydrogen here. So step 4, still Fe, this doesn't affect Fe. So let me just repeat Fe. I'm just going to repeat my Fe just as it was. Fe 2 plus. This doesn't affect Fe. No business here. So let's just repeat Fe as it was. Now, if you don't know what Fe stands for, I'm reminding you Fe stands for ion. So Fe3 plus is not affected. Just repeat it. Now let's focus on the one in red because those are the ones that involve oxygen and hydrogen, and we have to think. So they're saying that balance the hydrogen atoms by adding H plus. So I have to balance the hydrogen atoms. So let's repeat everything before we do the balance. Cl2, we have O7. Oh, that doesn't look good. So we have 2 minus, and we have something, the arrow here, and now we have 2 Cr3 plus, we have plus 7H2. Oh, great. Now it says balance hydrogen by adding H plus ions. So how many hydrogen do we have? That's my next question. Look, there's 7 here. It's affecting everything here. So it's affecting the hydrogen, it's also affecting the oxygen. So 7, now there's 2 down here. So 7 times 2 is 14. So there are 14 hydrogen ions on the right hand side. So there are 14 hydrogen atoms on the right hand side. So how do I balance it out? They're saying you balance it out by adding H plus ions. So where do I add H plus ions? I have 14 hydrogen atoms here. Where do I add the H plus ions? And how many H plus ions do I need to add to balance this out? Remember, I have 14 hydrogen atoms here. So I need 14 hydrogen ions. I need to add them somewhere. Do I add them to the side where there's already 14, or I add it to the other side where there's no, where they lack hydrogen? I'm going to add it to the side. So let's add plus 14 H plus. That's what we need to do. 14 H plus. This is what is going on. Great. So we are one step closer to finishing our final work. So we're still continuing with this. So we just completed step 3 and step 4. I need you to write down, just write down whatever you have here. If you've not been following me, please get your notebook out, write down. We are at step 3 right now. Write down what you see from step 3. Write down what you see from step 4. Great. So we're doing a good job so far. Let's do this together. So please, I'm just reminding you. If you've not written this down, please let's write it down, please. Let's write it down. I needed you to write this down before we move on. I want to make sure you're following. You're following with me. You're following me carefully. So let's write this down. Step 3 and step 4. Write it down in your notebook. Make sure you're following. So now, I'm assuming that by now you've written it down. Because of time, we need to keep moving on. So I just follow step 3, step 4. Now let's see step 5. Now step 5 says that balance charges by adding electrons. So step 5 is just a continuation of step 4. So to balance charges by adding electrons, we need to look at the charges. So first of all, let's look at the charges we have. So let's start with iron. Let's start with iron for step 5. Let me write the iron. That was what was in yellow. Our iron was still Fe 2 plus. It was 2 plus, and now it was Fe 3 plus. We are balancing the charges by adding electrons. So how many charges do we have on the left? On the left hand side here for iron, we have, what's the charge for iron here? If you look at this, we have we have 2 plus here. But you look here, we have 3 plus. They are not equal. Okay? They are not equal. This is 2 plus, this is 3 plus. It means that this is this is 2 electrons lost. But this is 3 electrons lost. So there are 3 positive charges. So the difference is that 1 electron is the difference. Okay? So I put plus, then I put just 1 electron. What I'm doing is I want this negative to affect and reduce my positive by 1, so that now they can be equal. Because the goal is that I want both sides to have what? The same charge. So now I have 2 plus here. Now when this electron is added to this, we're going to end up having what? -2. That's the final goal. We're going to have -2. That's our final goal. Okay. So now we just balance the charges. By adding this electron, we just balance the charges. Okay. Now let's focus on the one that was in red. I hope you're with me. For the one that was in red, if you're looking back from what we had here, we had Cr2O7 then plus 14H plus. So let's repeat that. We have Cr2O7 2 minus here plus 14H plus ions. And that was giving us what? C2R3 plus. We have 2CR3 plus. So we're just rewriting whatever we had back there. That's 3, by the way. Was there any plus? Yeah, we had plus 7H2. Oh, let me make sure I'm on the right path. Yeah, that was the same thing we had there. Great. So whatever we had, good. Now it says balance the charge by adding electrons. Okay. Now we're going to add electrons. So let's look at it carefully. Let's start with the charge of C2. Okay, let's start with the charge for, sorry, the charge for Cr. We have Cr. So look here. See this Cr, this Cr is just Cr here. So no charge. This Cr has, this Cr is just Cr, no charge. This Cr here has 3 plus, but this 3 plus is affected by this 2. So 2 times 3 is 6. So this Cr on this side has plus 6. Only this Cr has plus 6. You see, only this Cr. I don't want to confuse you, so let me just take that off in case somebody thinks that I'm just trying to help you to see the charge there. But that Cr has plus 6, and we all just saw that. So this Cr's 3 plus here multiplied by 2 gives you 6. Let me just write it down here, maybe if that helps. So it has, you see that, so you have the charge as well, 6. So there's 6 plus. Okay, let me write that. Well, I don't want that to confuse anybody. Let me clean that and write that well. Yeah, now everything is gone. Interesting. So we have 6. Good, 6 plus for the CR. So we need to do something. We need to do something here to equate the charges for CR. So we're going to put plus 6. So sorry, we need to look at this carefully. I want to make sure we're doing so. What we are doing is we are balancing all the charges. So we are not balancing only one charge. So let's look at every charge on the left together. Then we look at every charge on the right. That will give us a good approach. So we are right. This is C plus, okay? This is C plus here. So let's not put anything anywhere first. Let's look at all the charges on the left. After we look at all the charges on the right, that will help us. So let's start with 1. So let's say we know that this is C plus. So we know that this is 6 plus. We know that this is 6 plus here or plus 6 here. Let's look at the charges here. Okay. So there's no charge. Look at this. There's no charge for any element here. So the total charge for this whole side is going to be only plus 6. I hope you can see that. It's going to be only plus 6. Okay. Which is just from this. There's no charge here. So let's put 0. This is 0. There's no charge here. So in all the total charge, okay, I want to find somewhere to write this. So let's say I'm going to do an umbrella here. Look, the total charge here is what? Plus 6. As you can see, it's just plus 6. Let's come down here and see. So if you're looking at CR, if you're looking at CR from here, looking at CR, here is 0. But look, everything here has a charge of what? Minus 2. So this minus 2 is a charge sitting here for everything here. Good, minus 2. So let's write minus 2 under here. It's the charge for everything sitting here. Now look here. There's a total charge. There's plus 1 here. This 14 is affecting everything here. So we have a total charge of what? Plus 14. So as you can see, we have plus 14 against minus 2. That is going to leave us with a total charge of what? What do you think? We have plus 14 minus 2. That is going to leave us with a total charge. Let me see if I can write. Let me see if I can write an umbrella here. So let's say we're going to have a total charge. I'm writing everything. We're going to have a total charge that will be equal to, let me write it here. We're going to have a total charge of plus 12. Does that make sense? 14 minus 2. You have 14 minus 2. So total charge of plus 12. So this is plus 12. This is plus 6. The charges are not balanced for the ones in red. So what can we do? What do you think we can do? Anybody? Think about it. This has plus 12. This has plus 6. We need to make them balance. They're saying that balance charge by adding electrons. So we are going to add an electron, a number of electrons to the left hand side to make it balance. We are going to add, so we're going to add plus 6 electrons. Does that make sense? Plus 6 electrons. So that this 6 electrons here is going to affect this plus 12 and reduce this plus 12 to what? 6. So that now we have plus 6 plus 6. Did you see what is happening here? Do you see what is happening here, everyone? So now what we have, so now let's write in red. Let's write our equation in red again so that we see it clearly. So our equation in red this time is going to look like this. It's going to look like a very long equation. I want to write it nicely. So I'm going to use this space. Everybody, please bear with me. I'm going to use this space. So our equation in red is now going to look like this. We're going to have a long equation for step 5. I want to rewrite it so that you see it. Okay. So now we're going to have step 5. It's going to look like this. We have C R 2 Cr2 O7 2 minus plus 14 H plus. Now remember we just added plus 6 electrons. So let's write that. Plus 6 electrons. That'll be the final one for the left hand side. Now let's bring our arrow here. And we're going to write the right hand side. I hope you're all following. So this is just for only the ones in red. Then our right hand side, we didn't add anything to the right hand side. So we're just going to have C2 Cr3 plus. Then plus our 7H2. Oh, so that's our final equation for the one in red. We just added a 6 electrons to balance it out because this was plus 6, but this was plus 12. So we brought a negative 6 electrons. So that's what we have here. We're going to have Cr2O7 raised to the power minus 2 plus 14H plus 6 electrons, all giving us 2 Cr3 plus 7H2O. Okay, so we just fulfilled step 5. Good. This is long, as you can see, so write it down. Make sure you're following. Make sure you can see what is happening, everyone. Great, great. Make sure you can see what is happening here. Make sure you can see what is happening here. This is important. Make sure you can see what is happening here. Great, 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 great. Great. So now let's go. Step 6. Step 6 says that multiply the two half reactions. Please make sure you've written step 5. I'm going to step 6. Step 6 says that Multiply the two half reactions so the number of electrons in one reaction equals the number of electrons in the other reaction. So we are looking at the number of electrons to make sure they are all the same. We're comparing the two half reactions. So look at in our half reaction in red, our electrons, the number is 6. Look at the half reaction in yellow. Can you see that? For the half reaction in yellow, the number of electrons is just 1. So then we have to multiply the whole half reaction by 6 so that they can all have the same number of electrons. So let's do that. So it means we have to multiply all the half reactions in yellow by 6 so that they can be equal. So initially our half reaction in yellow was just Fe2 plus, just repeating what we have up there, giving us Fe3 plus an electron. Do you see that? Plus an electron. That's what we have there. Okay. Now to help us, what do you say we're going to do? Multiply by 6, just because the rule says that the number of electrons in one half reaction should equal the other. The other half reaction has 6. So let's multiply everything in this half reaction by 6. So we multiply this by 6, multiply this by 6, and we multiply this by 6. Great. Then now we're going to have equal to, now the number of electrons are equal. So let's repeat our half reaction in red because we don't have to do anything to that. So we're going to have Cr, just repeating what we have here. Cr2 0.7 2 minus plus 14H plus 6E minus, all giving us 2 Cr3 plus 7H2O. And that's what we have. Okay, great. So now we have step 6 accomplished. We followed what step 6 asked us to do. We are almost there. If you've been with me till this time, just know that you're almost there. We are almost at the final lap. So we just completed step 6, step 5 and 6. If you've not been following, I'm very worried for you because as you can see, it's a long procedure. You need to follow step by step. So let's write this down. So we just went through step 5 and step 6, and we are almost there. We are almost there right now. So let's see what step 7 is asking us to do. Step 7. Let's go to step 7, everyone. If you're still writing, you can pause it. It's a video, you can pause it whenever you want to. Step 7 says that add the balanced half reactions. So the first thing is add the balance. So we're just going to follow this before we follow the rest. Add the balanced half reactions. So at this point now, we want to write all the reactions together. So let's start with the ones in yellow. Let's write the ones in yellow. We're writing all of them together. So let's write all the left ones together after we write all the right ones together. So let's start with the left one. We have 6Fe2 plus. So that was in yellow. So I'm still going to write it in yellow. We have 6Fe 6Fe2 plus Cl2. That's the red ones. I'm writing the red ones. Plus Cr2 O7 2 minus, yeah, plus 14H 8 plus mhm, plus 6E. Do you see that? We have all of that here. Now let's start with the yellows that was on that side. We have the yellows. The yellows we had on that side was we have 6Fe3 plus. So I'm just gonna write that 6Fe3 plus. So 6Fe3 plus 6 electrons. So plus 6 electrons plus 6 electrons. Why are you doing this? Good. Plus 6 electrons. So we're just writing what we have here. Plus 6 electrons. Then now let's write everything we have on the right side for the red ones. So the red ones plus 2Cr3 plus. So plus 2Cr3 plus. Okay. Plus 7H2O. So plus, we're almost there. 7H2. Oh, so we almost made it. Plus 7H2O. So this is the final equation. We just follow step 7. The first part, it says that add the balanced half reactions together. The last part says that cancel species that appear on both sides of the equation. So we want to see any species that is on the left and is also on the right. We need to cancel it out. I nearly canceled this out. I nearly was about to cancel this, but this is 2 plus, this is 3 plus. They are not the same. Now 6E minus or 6 electrons is the same as 6 electrons. So let's cancel it out. Let me find a different color to do the canceling out. So this cancels out this. So now we just obey step 7. Step 7 said cancel the species on both sides that are redundant. Okay, so we just obey step 7. Okay. Now after obeying step 7, how does our reaction look like now? So the final reaction, I'm going to write the final reaction in the same color. We're going to have 6Fe2 plus Cr2 3 plus 10 plus 7H2. Oh, so that's our final, how our final equation looks like. So this is our final equation. This is how it looks like. As you can see, it's very long. So let's see. Are we done? Okay, so this was the equation that was given to us. This was the equation that was given to us, and we're supposed to write the balance equation, and this is what we got. So this is the same as the final answer we had. This is the final answer we had. It's the same thing as you can see, CFE2. You can compare it, you realize it's the same thing we have there. So they're saying that do a final check. This is just the last step. Final check. Check if the atoms on the left and the atoms on the right are the same. Check if the charges on the left are the same, and then you're done. So Fe, we have 6 Fe here and 6 Fe here. So 6 on the reactant side, 6 on the product side. We have um we have 2 CRs on the left. This is it, 2 CRs on the left. This we have 2 CRs on the left here. This 2 is here. Remember this 6 Fe is here, this 6 Fe is here. That's why we put the 6. For oxygen, we have 7 oxygen here, and this 7 is affecting this oxygen. So we have 7 on the left, 7 on the right. Hydrogen, we have 14 hydrogen here. 7 times 2 is also 14. So we have 14. Let's look at the charges on the left. The charges on the left, we have 6 times 2. So charges on the left, let's see it for yourself. 6 times 2 gives you 12 here. 12 minus 2 gives you 10. Then now 10, 14. So 10 plus 14, that gives you 24. If you didn't see what I did, this is 12 plus. This is minus 2. This is 14 plus. So if you add all these, you're going to have 24. Because 12 plus minus 2 gives you 10. 10 plus 24 is 24 plus. So that's the charge on the left. Look at the charge on the right. 6 times 3. So if you're looking, this gives you 18 plus for charges. 2 times 3 gives you what? 6. So that's 6 plus. 6 plus 18 gives you 24. So as you can see, this is equal, this is equal, this is equal, this is equal, and it's equal. So finally, we were able to balance the equation. That's our final equation. So this is the balanced equation. And it's the same as what we had here. This is it. So that's our balanced equation. This was our question. This is our balanced equation. And that was the check. So write a balanced equation for the reaction between dichromate ion and ion 2 to yield ion 3 and chromium 3 in acidic solution. And this is what we end up with. This is what we end up with. Okay, so that's the final answer. That's the final answer. That's the final answer. Great. This is the final answer. Great. So please, as you can see, this is a long step-by-step procedure. I'm happy this is a video. Pause it, go back, look at this over and over and over and over and over until you are satisfied that you understand this. Please. And I want you to, you know what, I'm not even going to tell you to try and do this. Just go back, look at this, And I want you to go back and try and solve this on your own. Go back and try and solve this. So just take this same question here. Try and solve this question on your own. Right? Like solve this question you're seeing there. Write a balanced equation for the reaction between dichromate iron and iron 3. Solve this as if it was a question, new question for you. Solve it on your own. Try and solve it. That's what I mean. Try and solve. Make sure you understand. And try and solve that and send that to me as a proof that you watched this video, so that I can give you a participation grade. All I need is try and solve that and send that to me. We just did it together. So try and solve this and send this to me. Follow all the steps. Try and solve that to me and send it to me. Okay? Thank you so much for your time. And hopefully I see you soon.